Now, I do have some code commented out here for use in later examples, so ignore that for right now. What we're going to be looking at right here is the implementation of a non-overloaded method. In this case, I have a method defined called square_me. If you'll notice, the signature of the square_me method is a public method, that's its accessibility level, and double is its return data type. The name of the method is square_me, and it accepts a single parameter, a parameter I'm calling base val, and the data type of that parameter is a double. So that means that I have to either pass in a value that's typed as double or something that's implicitly convertible to double. Now, the return value of the method, therefore, has to match this data type. Since I have defined this as a data type of double and its return, then whatever data type I return must be double or convertible into double. Math.pow is actually a method call from the math class. The system.math class contains a method called pow that we can use to take a base value and then raise that to a specific power. So the pow method has two parameters, the base and the exponent. I'm taking this base val and raising that to the power of 2 in this particular example. Since math.pow returns a double data type, and I'm returning the result of math.pow in my method, then the data types do in fact match up. To call this method, I'm declaring a variable of data type double x, and setting that equal to a call to the method square_me, passing in the value of 5 as a parameter. Let's go ahead and execute this and see how it works. Well, 5 squared, basically 5 raised to the power of 2, is 25. So it looks like we're getting the results that we would expect at this point. Let's go back to the code and take a look at a different example. I also have created a method called raiseBase. What raiseBase allows me to do is specify the base and the exponent. However, raiseBase is an example of an overloaded method implementation. You'll notice that I have two implementations for the raiseBase method. The first implementation takes a single value here, a double base val. The second implementation defines two parameters, a double base val and the exponent, int power. Now, other than the parameters that are being passed in, you'll notice that the signatures of those methods are exactly the same. They have the same accessibility, they have the same return value data type, the same other modifiers. So the only way really to distinguish which one of these methods is being called is by the parameters that are being passed in. In this case, if I make a call to raiseBase and I pass in the values of 5 and 3, two parameters, then by necessity we must be calling the second implementation of raiseBase, the one that accepts two parameters. So if this is the case, then we should be taking 5 and raising that to the power of 3, instead of the default behavior, which is the base value raised to the power of 2, which would happen if I only passed in a single parameter. Let's go ahead and execute this as is, and look at our results. Well, the result tells us that we have 125, or in other words, 5 raised to the power of 3. What if I were to go to the call to raiseBase and take out that second parameter? Removing the second parameter, I'm actually calling the first implementation of raiseBase instead of the second. If I execute, I would get the result that I would expect, which is 5 raised to the power of 2, or in other words, the definition of the overloaded implementation of raiseBase.